Okay, so on this exam 2 review, let's work through a couple of probability questions. For example, number 24. E and F are two events. The probability of E and F is 0.15, and the probability of E is 0.4. We're asked to find the probability of F given E. Just by applying the rule, we know that the rule for the probability of F given E is the probability of F and E, or E and F, the probability of them both happening at the same time, divided by the probability of E. And now we just plug in the things we have. For this probability, F and E is 0.15, and the probability of event E is 0.4. So 0.15 divided by 0.4 makes 0.375. It's pretty similar for the next one too, number 25. Two events are independent. The probability of E is 0.7 and the probability of F is 0.2. We want to find the probability of E and F, the likelihood of them happening together at the same time. The probability of E and means multiply by the probability of F, given that E has occurred. However, since the events are independent, the conditional probability of F given E is no different than just the probability of F. So the probability of E, 0.7, probability of F, 0.2, multiply those guys together per 0.49. The next one, number 24, uses probability rules as well. A single die rolled twice. Find the probability of getting a 4 the first time and a 6 the second time. So there's two events. We want the probability of a 4, and means multiply the probability of 6, given that we've already rolled a 4. However, we're just rolling the die twice, so the second event is independent. The probability of getting a 4 the first time is 1 out of 6, and no matter what we rolled on the first time, the probability of getting a 6 is still 1 out of 6. There's 1 6 on the die, no matter what was rolled before. So this guy, that 4, doesn't matter to us. 1 out of 6 ways to get a 4 first, 1 out of 6 ways to get a 6 second. That's 1 out of 36. A similar approach can be taken here for number 27. There are 6 Democrats, 8 Republicans, and 5 independents in a sample. So a sample size of 8 and 5, 14. 8 and 5 is 13 plus 6, 19 total. 2 people are selected. We want the probability of getting an independent and then a Democrat. So we reach in there twice. We want the probability of an independent times for and the probability of a Democrat, given that we've selected an independent already. So the number of ways to get independent are those 5 out of 19 when we reach in the first time. But now we've already selected one, so when we go back the second time, that's where the conditional probability is there. Given that we've kept one, there are now only 18 available in the sample. And the number of those that are Democrat is 6. So multiply those guys together, 5 out of 19 times 6 out of 18. Is 0.0877, or as a fraction, 5 out of 57. I prefer to round to 4 decimal places there.